So the first question, pretty simple, straightforward, is around RL transient analysis. And the student sent me a pretty simple, straightforward question. And this is something that I find people making mistakes. So I just want to quickly remind you guys. The student is asking, I just wanted to confirm that the time constant of RL circuit should be is it L over R or R over L? I'm confused how it gets used in the formula. So the short answer is that the time constant of RL transient response transient circuit is L by R, as it is shown in the slide over here, as I've explained it in the on-demand, as I've explained in the live training, and yeah, okay, it's given as such in the reference handbook as well. Now, the reason for students' confusion, which I can explain you guys a little bit, is the fact that when we start using this in the formula, okay, so when you look at the formula over here, the way that the formula works out is that you have e to the power of minus r by lt, okay? Does it make sense, guys? So I'm going to write this here, e to the power of minus r by lt. So the students think that, e to the power of r by L, so this is tau. Whereas in reality, when you're dealing with the RL transient or RC transient, this equation actually is, this component is actually e to the power of minus t divided by tau, where tau is the time constant. If we are dealing with RC transient, it is pretty simple. It's simply e to the power of minus t divided by RC. Okay. Now, as I've explained to you that your tau is equal to L by R, correct? This becomes e to the power of minus t divided by L divided by R. So this R is 2 levels down, correct? So if I have t divided by L divided by R, when I change this into a multiplication sign, it becomes t multiplied by R by L, basic math, right? Are you guys following me? So this is what happens over here, and that's how you end up with R divided by L times t. Does it make sense? Okay, so the time constant is still L by R. It is not R by L. And the way that this graph is labeled is that this is tau, this is 2 tau, and then 3 tau, and then 4 tau, and then 5 tau, and so on. Time constant is L by R. It shows as R by L in the formulas because of this detailed explanation that I have just provided you. Okay. And again, you don't even need to memorize. Given the fact that it is provided in the reference handbook, this should be a non-issue. So if it is a non-issue, if it is so obvious, then why am I wasting your time and my time on this? Because students routinely mess this up. Okay, so the next couple of questions are interesting questions dealing with RC transient. We're going to deep dive in them a little bit. RC, so this is RL transient. So this was my response to the student. Tau is equal to L by R always. Okay, it appears as R by L because of this explanation that I provided you. Okay, RC transient circuits. Let's dive into it now. RC transient analysis. Now, one of the things that I have explained to you in the on-demand course, in the live training, with the help of the quiz problems, mini exams, homework assignments, is that whenever you're dealing with frequency response, RC or RL transient analysis, the reference handbook actually contains, for the most part, everything that you need. But interpreting it properly is still your responsibility and a fair test of your competency. Okay? Now, whether or not you're able to interpret the variables properly, whether or not you're able to identify the initial voltage and separate it from the voltage as a function of time or the external voltage, that is on you. They don't have to spoon feed you. Okay? So let us go through this question that I received from the student. And the student is saying that when the switch is open, we treat it as an open switch. There's no rocket science, pretty simple, straightforward. As two open terminals. meaning that there is still voltage in the circuit. Well, let's see how the question evolves, right? There's still voltage in the circuit. If I was writing this email or asking this question, I would say that there is still a voltage source present. When the student writes it as there's still voltage in the circuit, it becomes a little bit vague. And a lot of times, as I've explained to you guys before and multiple times, that this lack of clarity, generally speaking, results into loss of points on the exam. So be very clear in your thinking, okay? Or as if no voltage being applied on the circuit, okay? So saying that when we open the switch, does that mean that you still have voltage in the circuit? Well, the short answer over here is yes, but how do you define the circuit? Okay, how do you define the terminals? Where are you measuring? It depends. Okay, or as if no voltage being applied on the circuit. Well, if you open the circuit, depends on where you are measuring again. Maybe certain parts of the circuit may still have this external voltage being applied across them. So it really is a function of where you are measuring and where the terminals are. So one of the other things that I notice is that a lot of times we try and go for black and white answers. Okay, just tell me one solution, one response that will be applicable to all the cases. In reality, the fact of the matter is that most of the time, it depends on the scenario. And students, if they are not approaching things from first principles with basic fundamental concepts and pieces of knowledge, they actually don't like this. It depends. They start rolling their eyes. Okay, another it depends, right? So if you're looking for shortcuts, they will not work in every single scenario. But if you're working with first principles, you will never be uncomfortable dealing with a it depends scenario. And 95% of the things that you're going to see are it depends scenarios. Does it make sense, guys? So what is the student asking me over here? A black and white answer. Okay, tell me when the switch is open, do I always treat it as irrelevant, the voltage source or the current source or the power source? Or will the voltage still be in play? Well, it depends on how the circuit is, what is happening when the switch opens. Okay. And we've done some really interesting practice problems in the homework assignment. Even when we opened the switch, the voltage source, the power source was still in play. Okay. Does it make sense, guys? Okay, the question stems from quiz. So he's asked a very simple question, frequency and transient response, problem number 3. So this is from the quiz. The solution states that the initial voltage is 0 instead of 10. Okay, I can make the question say whatever I feel like. The examiners, the testers can ask you and frame the questions however they feel like. It's not that the voltage had to be 0 or 10. It's up to my discretion. Can you explain the reasoning, please? So, I mean, I chose 0 volts as the initial voltage. I could have chosen 1000 volts as the initial voltage. There's no reasoning. There's no rhyme or reason behind it. Okay, so again, trying to anticipate too much and not absorbing what is going on can sometimes freeze you. Okay, is the RC value calculated? So this is sort of a continuation of the same email. Is the RC value calculated after the switch is switched when t is greater than 0 or before? This is interesting. In some scenarios, resistors are taken out of the mix. And again, if you try and develop your understanding based on models, okay? Remember, philosophically, psychologically speaking, the mental models that we create in our life, and it is encouraged, to actually have some mental models because it makes our life easier. But a mental model is not a reflection of the reality, right? So you can pull up Google Maps, or you can pull up a map on a piece of paper, or you can, find it on online. It'll show you the map of US. It shows you the map of Canada, right? And the rest of the world. Okay. Is the map good enough for you to go from point A to point B? It depends what you're trying to do. If you're an airline pilot, if you want to start out at LAX and land at JFK, can you print out a map and then make it happen from LAX to JFK? No. It will just give you a general direction, right? But it's not good enough, right? So as helpful as these maps and mental models and frameworks are, they are no substitute for actually digging in deeper, right? So I find a lot of students doing this, especially with circuit analysis and RC transient, as I mentioned earlier, RL transient, as I mentioned earlier, are essentially an extension of circuit analysis, just like most of the problems that we did in electronics were an extension of circuit analysis. 75% of the stuff was circuit analysis. The remaining 25% of it was device specific electronics knowledge superimposed on top of circuit analysis. Okay. So this question, in some scenarios, resistors are taken out of the mix, and in some scenarios, they are being shorted or whatever. I never got a clear answer when I was taking my circuit analysis course. Okay. So yeah, hopefully this will help clear things out, guys. Okay. Now let's read through this very simple, straightforward question. I think this is a 1-minute problem. If you have enough practice and understanding of how to deal with the RC transient analysis problems, this is not even a 3-minute problem. And the student has a list of, doubts around it. Okay, so let's see how we deal with it systematically. The initial voltage across a capacitor in RC circuit is equal to 0. Do you guys agree that so this is the equation that we are given in the reference handbook, right? This equation is given in the reference handbook, correct? VC0, this parameter, this guy, is what? Initial voltage across the capacitor in the transient circuit, correct? Now, the first line that I've mentioned over here, that the initial voltage across a capacitor in the RC circuit is 0. Do you guys agree or disagree with this? Is it good? Do you need to think about any other scenario? Is there any other variation that possibly applies, any permutation combination? Or is this legit? VC0 is equal to 0 volts. Is it good enough? What do you guys think? Yes? No? Maybe? It's all good. I think it's as straightforward as it can be. Straight as an arrow, right? Calculate the capacitor voltage as a function of time. So what is unknown? Vc of t. If the switch closes at t is equal to 0 and connects R and C to a 10-volt battery. So let us take it one step at a time. We figured out that the question is asking for Vc as a function of time and it is unknown. Everybody is on the same page? Everybody is on board? Right? Yes? Yep. Okay. Switch closes at t is equal to 0. I'm just reading this from the problem statement. And connects R and C to a 10-volt battery. Now, how difficult it is, guys? I have a switch. Sketch it out. Okay. I'm going to write this. And this was a problem statement. I didn't provide you a diagram. I expect you to be able to do that. Okay. In a lot of advanced problems that we've done in the homework assignment, I have provided you multiple diagrams, right? Not in this one. But despite that, you can see that the student has a list of doubts around it. Switch is closing at t is equal to 0. And by closing the switch, you are connecting a 10-volt battery to R and C. Does it make sense? All good? Okay. Might as well throw that the switch closes at t is equal to 0. Okay. Switch closes at t is equal to 0 seconds. Okay. Now, if I don't do anything, right, with this circuit moving forward and just take a second to absorb what is shown here, right? Just take a few seconds just to absorb what's shown over here. Pull up the reference handbook, go to RC Transient, look for equations and circuits. Will you be able to connect the dots? Should be. That this is an equation that applies to this. Now let's look at what is given to us. VC0 is equal to 0 volt. I'm just going to make this 0. And all I'm left with is this. Now in this formula, VCT is equal to big fat V. That's how I mentioned it in the live class, if you guys remember, right? What was this big fat V? External voltage, correct? 10 volts, external voltage. That stays, correct? And then e to the power of minus t divided by RC. That's it. So this is a solution. Now, again, when you sort of ask questions very broadly and are looking for some quick response that you can memorize and apply to every single scenario, that is not the right approach to study. That is not the right approach to prepare. Okay. So this first question, in my opinion, it is too broad, and the answer is it depends. Is the RC value calculated after switch is switch when t is equal to 0 or before? So it is after. So the easy answer, the way I responded to the student is that this is after. So the C is C. C really doesn't matter, but it's really the R that the student is asking, because C doesn't matter. You could have had, before the switch was open, you could have had maybe some other resistor that was connected. When this switch was closed, maybe that resistor got shorted. Essentially, it is in that steady state when the switching has happened, whatever is left in series. That's another key point with the capacitor. That's the resistance that matters. Okay, so you can see that the series resistor is this, needs no other resistor. Yes, in some scenarios, we do take the resistors out if they're shorted. In some scenarios, we end up with a parallel arrangement in series with a capacitor. So those scenarios really depend. But you have to be very clear in your mind as to what the initial voltage is, VC0, what the external voltage is, V is equal to 10 volts in this case, whether that external voltage stays in the circuit. In this case, it does, because when the switch closes, that's when the voltage is applied. Okay. What is the value of R? Okay. Does it change? The R that we are interested in is the R that ends up in series with the capacitor during the steady state. Okay. So let's systematically break it down. And when you break it down systematically, you won't go wrong. Any questions on this? Okay. And when you reread the problem statement, you'll find that it's very simple. Unless you have your concepts clear, you can actually, tangle yourself into clarifications, concerns that are best addressed outside. You cannot figure these things out. Like the basics, don't expect to learn the basics during 3-minute per question examination. That's not the time to sort of deal with these issues. Now is the time to deal with these issues. Okay, let's move on. Next problem, another interesting problem. So in the solution of this question, sorry, this is sort of hidden. I'm just going to redraw this over here, right? So you have a resistor that is in parallel with a capacitor, external voltage source. Okay, so I hope this is clearer. T is equal to 0. it is opening up at t is equal to 0. You have a R and then you have a capacitor. And this particular question, the student is asking some clarification from one of the problems that we did from study guide in the on-demand course. So the student is saying in the solution of this question, the relevant formula is the same that the one the handbook shows when the switch is closing at t is equal to 0. I did use the one in the bottom, so that's the one he's referring to. See the second picture attached and obtain the same answer. However, this confused me a little bit in which formula to use in each case. And again, this is a different student, different question, different scenario. But what is the tendency? What is the tendency? What is that desire at the back of the student's mind? Tell me what I need to use. I'll just remember that in my mind and run off with it. Can you guys sense that? I mean, I teach hundreds of students, right? And depending on how a question is asked, I am able to quite accurately judge, okay, that what is the crux of the question. Okay. This confused me a little bit in which formula to use in each case. Especially because I see that in the first case of the handbook, there is a series arrangement between the resistor and the capacitor, while in the last case, there is a parallel arrangement. Does this configuration play a role in which one to select, assuming that the capacitor will be depleting its charge and the switch is open, charging when the switch is closed until the 5-time constant? Okay. So let us focus on the circuit, the way the circuit is given to us. Okay. I'm more than happy to sort of rework this problem with you guys in steps, okay, briefly. And then we will answer the question that student has, which is arising because of the desire and the tendency to sort of just understand which equation applies on which scenario, right? Not working through first principles. So this is a circuit that is given. I have a 10-volt DC source that is being simultaneously applied to the 10K resistor and a 200 microfarad cap. This is the switch, and the switch is opening at t is equal to 0. So this problem is an interesting problem that is in the study guide. I've had students ask me some questions about this problem. That's why I decided to sort of do this problem in the on-demand course as well. Okay. Now, without even lifting your pen, okay, without even lifting your pen, can you guys tell me that as it stands right now with the switch closed, how much voltage is being applied across the 200 microfarad cap? What is the voltage with the switch currently in its position? Isn't the voltage source 10 volt directly applied across the 200 microfarad cap? Is it a rocket science to identify that VC0 is equal to 10 volts? It's not. It's extremely obvious. You guys agree with this? Okay. Now, the formula that we used, guys, the formula that we used in the previous example, and the one that I'm using in this example as well, is this. That the voltage across a capacitor as a function of time depends on what the initial voltage is and what the external voltage is. Correct? Now, initial voltage, you guys are on board with me, right? VC0 is equal to 10 volt, right? What is the question asking? Is the question asking for voltage across capacitor as a function of time before switching or after switching? T greater than 0, right? What is happening at t equal to 0? Switch is opening. Correct? So after the switch opens, can you guys see that the circuit is going to look like this? You guys agree? That once the switch opens, this 10 volt is taken out of the picture completely, because technically this 10 volt is in series with an infinite resistor. So when I open the switch, let me just show you this from first principles, right? When I open the switch, what actually happens with this 10 volt battery is this. When I open, please listen carefully. When I open the switch at t is equal to 0, this 10 volt battery actually gets connected in series with the resistor. It does. And you know what is the value of that resistor? Exactly, infinity. It's an open circuit. This branch is an open circuit. And it is like any other branch. If I were to argue with you that I can see a million branches connected in parallel with this particular branch, okay? Would you agree with me? In this circuit, I see million branches that are in parallel with the 10K resistor. Do you think I'm right or wrong? And then I tell you that each one of those branches carries infinite resistance. Is that correct? For all practical purposes, that statement is correct. And because they're open circuits with infinite resistances, we don't care about them. And that's the reason why we don't care about this guy anymore. Listen, guys, at the end of the day, this is just Circuits 101. But Circuits 101 is going to help you come to your rescue if you have understood it from first principles. Otherwise, for such a simple, straightforward question, such a simple, straightforward problem, you can also be prone to these type of confusions that the student presented in this question. And then the tendency is, okay, tell me which formula I need to use for which scenario. That's not how it works. Okay? Is that clear, guys? Now let's dig into this formula. Why did I stick with this formula? I've explained this in detail in the on-demand course because this is the formula that tackles the charging and discharging of the capacitor. You don't need to memorize which formula needs to be used. It is all inclusive. Okay? So when t is greater than 0, what happens to this big fat V? Do you see the big fat V over here? That 10 volt source? What happened to it? Disappeared. Why? Because of this explanation that I provided you. Correct? So what are we left with only? We are left with the charge that the capacitor has accumulated during the charging phase when the switch was closed for an extended period of time, and now it is the capacitor's turn to discharge. How will the capacitor discharge? E to the power of minus t divided by RC multiplied by VC naught, VC 0. This is 10 volts, e to the power of minus t divided by RC. What is the value of resistor? 10K, the resistor that is in series. Okay. Now you look back at the questions the student has asked, and they seem a little bit frivolous, right? A little bit flimsy. Okay. Did you have to remember which of the 2, 3, 4 formulas you had to use? No. If your understanding was based on first principles, no matter how a question is asked. And trust me, we have handled far more difficult circuits, transient analysis circuits, elsewhere in the course. Some of the quiz problems are more challenging. Some of the mini exam problems are more challenging. Some of the homework assignment problems are more challenging. There are some problems in the study guide that are even more difficult than this. And then full and computer simulated practice exam problems, all of them, practice exams, mini exams under time constraint. So the focus, guys, is first principles. If you have first principle understanding, right? And this is what I hammer in my program. Don't go for shortcuts. Okay. Learn things from ground up, and you will be very comfortable and confident in dealing with any type of problem, both for the FE electrical exam and the P power exam. And as always, for additional practice, more sounder understanding, please make sure that you go through the on-demand content, multiple lectures, step by step, work through these problems. It's good to ask these questions, make use of the community, that feature that I have in my course, and do the homework assignments, quizzes, practice problems, and you'll be set. But please don't take shortcuts, because they have a way of coming back and biting you. And you don't want to be bitten on the exam, right? Struggle right now so that's what they say, right? Sweat during training so that you don't bleed in the battle. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE electrical and P power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE electrical and P power exam preparation programs, please visit my website, studyforfe.com.